review, do we remember how to work with exponents, the rules of exponents?
Just review it all.
Just basic, how do you simplify with exponents? So this is not going to be super duper complicated, but this part should, I hope, seem familiar.
Oh, these are fun. Not really fun, but
not bad. Okay, so when you look at something like that, what do you have to do first?
wait, did we do it this year already?
And not this year, algebra 2. Yes, if you have the a power on the outside, you have to do that one first. Okay, Nicole said distribute it. Do you do it by adding or multiplying?
Multiplying.
Yes, we multiply. Okay.
Add with the other thing.
And so, if you have a power to another power, you multiply, which is going to make that a to the 15 and b to the 6. Okay. Now, what should you do next?
Add.
You multiply the top, but when we multiply variables, what do we do? The exponents.
Add the exponent.
We add the exponents. So 2 plus negative 15 would be negative 13, and 3 plus 6 makes 9. Okay. Then, okay. And then, quick way, we know that when we move them from top to bottom, what do the powers do? They change sign, and we always want to have positive powers. So should I move the A's up or down?
Down.
I want to move down because I want it to become positive. So if I bring it down, it will become plus 13, and negative 4 plus 13 is really a to the 9th. Okay, which way do I move the B's? Yeah, I would want to move the B squared up, and I would subtract it when I change sign there, so I would get b to the 7th. So B to the 7th over a to the 9th is my final simplified answer.
Hang on, don't go
Right, one problem of the test, maybe? Okay, so you're saying we're good at the rules of exponents.
Can you do another one? No, we're
Hold-
terrible at them.
Thank you. Another little rule to check on. Do you remember how to take a root and turn it into an exponent? Yeah. So there's the question. Is it 2/5 or 5/2?
2/5, otherwise you got 1.
Yes. The index on your root is always the denominator. So that's a to the 2/5. That may come up in a problem. Okay. Here is, I guarantee you, there will be one of these on the test. And it is sometimes my most missed problem on this test. More missed than the log. Because we break the rules of exponents. There's something about if I start putting powers and your base is a number, people go crazy and start inventing their own rules. Can't do that. So I'm going to give you something simple like this. So I'm going to put a power on the outside. Am I allowed to distribute that negative 1 power if there's a plus sign in the problem?
No.
No, I cannot distribute it. Here, we were multiplying, so yes, you could distribute. Addition? No, you can't distribute. Well, if it was squared, we FOIL it.
It's a fraction.
Okay, what you need to do is you need to simplify the inside. We'll actually deal with that negative 1 power as the last step. So the big question is, how do you number-wise figure out what 4 to the negative 3/2 is? No! I warn you, this page of the test, you will not be allowed a calculator. Okay, since it's negative, where do you take something that's negative? To the bottom. So, okay, it becomes 4 to the positive 3/2. And same thing here, since that's a negative 1, we drop it to the bottom, it becomes positive.
Yeah, I don't know how that happened.
Okay, you don't know how that happened? You don't remember?
It's just one of the real ones, a negative, it goes to the bottom.
When it's a negative, yeah.
Wait, but why you put -1?
Okay. I can't distribute it, it's a plus sign.
Oh,
You
okay.
can't distribute it across plus sign.
But can't you move it to the bottom of a fraction technically?
You could put this whole quantity on the bottom of a fraction. And you don't really want to take that whole mess to the bottom in one big fraction. It's kind of ugly. You would rather simplify this than deal with the power at the end. Okay. Now, the question is, how do I figure out what 4 to the 3 halves power is?
It's like 4 to the third square, or it's the square root of
Yeah.
4 to the third.
It's 4 cubed in a square root. Okay. This is obviously just 1/2. It's no big deal. Okay. When you figure this out, 4 is not that big, so you could actually do this one either way. But if I put a bigger number in there, you would not want to cube a big number if I'm not letting you have a calculator. Okay. So you always want to do the square root first because it makes you get smaller. So square root of 4 would be 2, and then it says cube it, so I would get an 1/8. Yeah. So that whole thing actually turns out to be 1/8
Wait.
plus
Again,
1/2.
how did that happen?
Square root of 4 is 2.
Okay.
Then you cube it. 2 cubed is
So you
8.
do 4 separately from the 3.
Yeah. You do the square root first, and then you cube it. It's actually like you can say it's the square root of 4. You can actually put the cube clear on the outside.
I think I get it. Okay.
Okay. Because otherwise, if you have to cube it first, even if I had made that a 9, you want to cube 9 and then have to figure out the square root of that great big number. So you want to do the root first, then take it to the power. It makes it faster and easier. Yeah. No, sorry, I haven't finished copying it. Thank you. No. Sorry, I missed copy. No, it's still there. Sorry. So now, oh no, you have to add fractions.
That's not that hard.
That's about 4.
An 1/8 plus a half.
That's about 4.
Thank you. 1/8. 1/8 plus 4/8 is. That's 5/8, isn't it? And then the easy way, if you remember, a negative power on a fraction just makes the fraction flip. Negative powers make things flip upside down. So it becomes 8/5, and that's your final answer. Negative powers just literally move things from top to bottom. That's all negative powers ever do.
This might have been the first thing I've understood.
Quickly, yeah? Okay. So, anybody else with why, how? That follows?
Did you just really redo like everything functions from last year?
Yeah.
Great.
Most of this chapter is a review of last year. I may tweak a couple problems with a little more pizzazz, but basically, to get a handle on logs, you just need to do it twice. It just makes way more sense. Ever since I got to have pre-calc, and we get to do it again. Oh, sorry. Yeah, thanks. Okay. You guys have already done expressions this year with x to a power. We did x squared, x cubed. But what makes something an exponential function? What's in the exponent?
Good question.
A variable. Number.
Mostly review.
I don't know.
Okay.
Variable and the exponent.
So, a variable in the exponent. So, if the variable is the exponent, what's the base?
Probably a number.
The base is a number. If you're working with exponential functions, the base is a number, the variable's in the exponent. So, we say it's a constant base and a variable exponent. That's the big difference. And maybe you thought itty bitty teeny tiny bit of exponential functions in Algebra 1, but it's one of those topics that gets cut if you're running out of time at the end of the year. So you may or may not have seen it. Okay. Now, there are some restrictions on exponential functions that have been set.
Can't be negative.
What can't be negative? Which part? The base, yes. The base is always a number greater than 0. Okay, so it's always a positive number. Base cannot be 0. Okay, what good does it do you to take 0 to a power? 0 to a power is still 0. So we don't do base 0. We can do any positive number except 1. Why wouldn't you want a base of 1?
Because it just comes out to whatever you want.
It always comes out 1. 1 to any power is still 1, so it doesn't do us any good. So the base can't be 1 either. But it can't, so some people will say, well, why is it just greater than 1?
Because it can be a fraction.
It can be fractions. You can have a base of 1/2, 3/4. You can have fraction bases. They just have to be positive and not 1. Okay. Now, the exponent. Is there any limit on what number can be an exponent? Can you have positive exponents, negative exponents, fraction exponents? Yes. Exponent, x is any real number, yes. X could be any number you want. The power can be anything. Okay. But what will y come out to be if your bases are always positive? If you take a positive number to a power,
It's gonna be positive.
are you always going to get a positive number? So therefore, y is also always positive.
Well, what if you stick a negative in there? That's the point. So is B
Okay.
a constant base?
B is the constant base. B is the constant base. Okay, those rules are going to apply because Friday, when we do logarithms and we do the inverse and we switch the x and y's, these just switch.
So basically, y can't be 1 either. B can't be 1.
Well, y could be 1 because something to the 0 power is always 1.
I have a quick question. Right. Okay.
Yeah, so it could be 1, yeah.
How do you spell 0 or 4 or whatever that guy's name was to make it easy?
I'm going to get to you here shortly, and we'll be writing his name up there, so you just hang on. He's coming.
271.
Okay. Actually, I think I want to graph now. While we're discussing that, let's graph now. So, grab some graph paper. I always do the wrong one.
Everybody.
You have 13.
Okay, well, we'll graph the first function, then I'll kill it. Oh, no, maybe I should kill it now. It's the end of graphing. Okay, goodbye, people.